Okay, so hopefully you did your guesses for these this data. I'll show you what the data I'm going to use. Now you are going to use your data. I'm going to use this data, which I think I copied from a student a couple years ago, and they might have not been the sharpest knife in the drawer. So you go with your own data. I'm going to use this data though, and um, use your own. Use your own data. Uh, what's the plan? Well, the plan is then to generate a model for the percent of moon illuminated after T days. The first way we're going to do is to use logic like we did last time. So what are we talking about? Well, essentially all we needed was the minimum and maximum, right? And then we could construct the entire story. Right? The minimum and the maximum happened, well, the minimum would have been when the moon was new, right there, so 8-0, and the full moon, according to this person, according to this data, was after day 23. So if I go back to my model here, minimum was after day 8, it was 0%, and the maximum was at day 23 was 100%, right? And so after day 8, so this is day along the x-axis, and this is percent illuminated here. After day 8, it was 0, and at day 23, it got up to 100%, right there. And in between, notice we could have plotted all these points, but the method that we kind of learned yesterday, really only we needed the minimum and maximum, and assume that it's sinusoidal. Assume that it's going to be a cos function or a sine function of some sort. Well, which one are we going to use, by the way? Well, it doesn't really matter, but since it starts at a minimum, probably a cos graph, right? The goal is to write y equals a cos b. Now notice this is no pi's on the x-axis, so we're going to use this fancy one with the big B down here, x minus d plus c, and then we just got to pick off all these values. The amplitude, the period, the phase shift, which is d, and the vertical displacement, or average. Okay, so let's start filling them out. Well, the amplitude we know is, I'm going to change color for funsies. The amplitude is this much. Well, what's halfway in between? Well, 0 and 100, that's 50, right? And so what's the amplitude? The amplitude is 50 as well. 100 subtract 50 is 50, so therefore A equals 50. What's the period? Well, when we went from minimum to maximum, that was 15 days, right? 23 subtract 8 is 15, but that's only half the period, so I got to go 2 times 15 to get 30 days. And, that's reasonable. I think the moon cycle is closer to 28 days in a little bit, but 30 days isn't terrible. The phase shift, again, depends on whether you want a sine function or a cos function. Notice we could have a phase shift of right 23 days, and our cos function could start at its maximum. But usually we're okay starting at the minimum. I'm going to say, right 8 days. And then the conclusion is I'm going to have a negative cos graph, right? A flipped cos graph. So then, vertical displacement. The average or vertical displacement is 50%. The average moon illuminated is 50% between 0 and 100. That actually makes sense in this context, so that should be pretty good. Notice I'm actually just going to put, and I could use decimal 50 for 50%. I'm just going to use 50. It doesn't really matter for this model. A is 50. Cos of 2 pi over my period is 30 days. My phase shift was right 8 days minus 8, and then plus 50%. Okay, there's my model. Dandy. Now, have a look. Let's just try our model out here for one of them. So for here, I'm going to try day. So this is a model check. So day 13, I said or whoever, I scooped the data off. Day 13 was 12%, I said. Oops. 12%. And so on the model, so this is the table, the model, all I would do is I'd take out the X and I put in the 13. And I'm actually gonna put that into my calculator or try. 13 minus 8 plus 50. Do I have a graphic calculator somewhere? Yes, I do. Turn that baby on. Let's go. And second, quit is to go out to the normal calculator spot. Where to go, where to go, where to go. All right. Come on, you. Come on, you. There we go. 50 times the cos of, this is this bracket here, 2 pi divided by 30 times, and notice that this isn't in brackets, so this is actually times like I want, 5 bracket, and that bracket is this square bracket. I actually I did 13 minus 8 in my head all by myself there, so I'm hoping that's okay. Plus 50, and then I get an, oh, hang on. Oh, did you see the error? You guys were screaming for me to fix this. I hope. Right? I hope, oh, and now a mistake and the phone's ringing. Okay, I have to take a breather here. All right, some salesperson, but that gave me a chance to correct my mistake there. I can pretend that that was always there. It was always minus 50, a flipped cos graph. Of course, then I'm going to have to go back in here and fix this, unfortunately. So how do second function, insert a negative sign in there, and then let's just check and see how. 25. So the model says on day 13 that it's 25%. That little slice there is 25%. So notice that day 14 I said it was 25%, but who's right? Like, what's going on? Was my guess better, or was the calculated value better? Who knows? How accurate is this? Probably not that accurate, is it? And in fact, that's going to be our second method is to try and get a more accurate model. And that's the second solution, is using the TI-83. So if you have one handy or an emulator handy, you should put the data, all this data, the day, it goes into list 1 and the percent into list 2. Data management, folks, you should be excellent at this. But if you haven't taken data management, I'll walk you through it a little bit. Stat and then edit get you to the tables. Right? And there's list 1 where all the days go, and list 2 is where all the percents go. Now notice, more accurate would be putting all the data in, but Mr. Restall, by nature, is lazy, and I've done every other day. A sample. Actually, data management people would correct me by saying I did a sample of the data. What type of sample did I do there, data management people? Can you remember that, huh? Every other day is a systematic sample. Okay. Sorry there, function folks. Little chit chat aside with the data management people. Anyway, lazy. Every other day I put in, and then I put all the data in there, and now I'm going to use the calculator to come up with a model. And how we do that is under the stat menu, and I'll write some of these steps on the note later. Stat, and then I go over to calc, and I'm going to go down to not linear regression, not quartic regression, not these other regressions. There should be a trig regression. Sine reg. So sinusoidal regression. So unfortunately, this is actually going to give us a sine function instead of a cos function, but we'll be okay. We'll be able to see some of the things are correct or not. And bam, there it is. It worked away. I'm going to actually copy this if I can. take a screenshot and jam that in there, edit, paste, and then we'll talk about it. All right, so first of all, what did we do? Well, I'm going to give you some steps. So this is stat, and then edit, and then all the days, they went into list 1. The percents went into list 2, and then I hit stat, went over to calc, that's my little scroll button, to calc, and then I picked sign reg. I can't remember how far down that was. Maybe that was 7 or 8. But sign reg, and then this was the output. So what is this telling me? This is telling me that the function is y equals 52 and change sine bx plus c. Notice that this isn't in our nice form there, but b is 0.21 x plus c 2.97 about, and then plus 40, almost 47. So notice how close this is our logic model was this one. Negative 50 cos 2 pi over 30 x minus 8 days plus 50. Notice that our amplitude and our vertical shift should be the same. Now what's weird about the way that they gave it to us, it's not factored, and it's hard to see the b. Well, this value, the phase shift, doesn't really matter because one's a cos graph and one's a sine graph, but I'm really interested in seeing what the period is here, right? We wrote it as 2 pi over 30. What are they saying the period is? Well, this is the little b value, right? They're saying little b is 0.21, but we also know little b is 2 pi over the period. So if I wanted to find out what the calculator is telling me the period is, I could solve for that. And then divide there, 0.21, and I jam that into a calculator, and I get, well, what do I get? Let's put it into the calculator. Let's not just fart around here. 2 times pi divided by 0.21. They're saying the period is 29.9 days. So pretty much the same as what we said, about 30 days. Okay. Wouldn't it be nice to have a look at this data? Well, the data management folks, I'm going to get rid of these questions for right now. Can I do that? Yes, I can. Wouldn't it be nice to have a look at this data and see what's going on? Well, certainly I could, and data management folks know this. Once I put the data in, right, and I got the data in all these lists, I can actually plot the data on the stat plot menu. And we've had some practice with this, but here we go again. Second y equals gives us the stat plot. Notice all the plots are turned off. I could turn that back on. And list 1 is the x list. List 2 is the y list. And if I want it to pick the window settings, remember we had the window settings from the 3-minute review, we could press zoom trig, but this isn't a trig function anymore. This is actually a stats thing. We typed everything in the stats thing, in the stats menus. So we can put in zoom stat 9, and again, I'll write these steps in a second. And oh, there's our sine function, right? Now, oops, I forgot to delete off the trig function from before, so it's trying to graph that. I'll go back and erase that, and then have another look at my plot, and there it is. So I'm kind of interested in, what does my function look like compared to the model we came up with in class? And I can type that in. I can type in, this is the model that we came up logic style. Cos of 2 pi divided by 30 x minus 8 bracket, and then that ends that bracket, and then I got to end this bracket, so bracket plus 50, and have a look. So this wasn't the one the calculator gave us, right? So it doesn't look so bad. It looks like it's matching it pretty close. But now we could also compare that to the one the calculator did. And I could type all that in, but there's a slick way here. There's a slick way to do this, and that's using this vars thing. I'll put these steps on the note in a second. Vars, go down to stats, over to equation. The regression equation, I can copy it right in there. Look at all the decimal places. It's a mess, but here is then the regression equation. And notice it dips into negatives for a second there, which looks a bit strange, but that's because I didn't put all the data in. And notice if I press trace, right now I'm on the plot, but I can jump from one model to the next if I would like to. And soon we'll actually use this data to our advantage when we're talking about IROC. All right, so here, what were some steps there? First of all, to get the plot. I'm going to change color. To plot, what did I do? I pressed second, y equals, and that was a stat plot. And then I hit zoom button, and I think it was zoom 9 for the zoom for the stat. Zoom 9, which was zoom stat. Okay, that's one gem that we did there, and then we entered the equation in y equals. And to copy the reg equation, the regression equation, what we did is we went y equals and got into a new spot. I'll do that again. And then it was vars down to stats 5, and then over to EQ, and then press enter. Okay, so what was that? That was vars down to statistics, over to equation, and then select reg equation. Which model's better? Well, geez, we still don't know. Okay, and this is up for debate. I guess you could talk about is the regression equation better? Certainly was more hassle than our logic method. When is the moon waxing? Now I got to remember what that means. How am I doing for time here? This might be, yeah, I got to stop here. I'll go into the questions in part 3, the dreaded part 3 video.